This video is about the topic of analog Chebyshev filter. Chebyshev low-pass filter is optimum filter compared to Butterworth filter. Optimum in the sense that if specified del P and del S is given to us, the order of filter that will be required to satisfy that specification will be the lowest compared to Butterworth. And this Chebyshev filter also gives us narrowest transition band. As compared to Butterworth filter, we see that there are ripples, that is, we have equal amount of the graph characteristics is not monotonic. It has ripples, that is, it goes from maximum to minimum with equal altitude of maximum and equal altitude of minimum. Here in this diagram we have ripples in the pass band, whereas it is monotonic in the stop band. It could be otherwise also, that is, having ripples in the stop band and monotonically decreasing in the pass band. So this Chebyshev low pass filter is also called equi-ripple or equal ripple filters. Now this is an example of type 1 filter where there are ripples in the pass band, whereas if there would have been ripples in the stop band, it would have been called type 2 Chebyshev filter. We are interested in type 1 Chebyshev filter because we are interested in what is going on in the pass band. Ripples in the stop band is not a point of concern for us. As it is a stop band, we are to just satisfy it, and whatever goes on in the stop band is not our concern. For Chebyshev filter, Haj omega is written as A by root over 1 plus epsilon square Cn square of omega by omega p, where Cnx is defined as cos n cos inverse x, where mod x is less than 1, and cosh of n cosh hyperbolic inverse of hyperbolic cos x, where mod x is greater than 1. Mod x less than 1 means if we compare it with the Chebyshev equation, in our case x is omega by omega p. If mod x is less than 1 means omega by omega p is less than 1. That is, omega is less than omega p, which tells about the pass band. And we know cos is an oscillatory signal which justifies the ripples in the pass band. Whereas when mod x is greater than 1, then we are talking beyond the pass band, and hyperbolic cos is monotonic, so which justifies the monotonic decrement beyond the pass band. Now from here we can also say that C0x would be 1 and C1x is x. Now if we take cos inverse x as theta, then cos theta is x. We know C0x, C1x, which are evident, but what about C2x? Now C2x can be written as cos of twice theta, because here we have written cos theta is equal to x. So cos twice theta is 2 cos inverse cos square theta minus 1. So if we replace cos theta by x, C2x comes as 2x square minus 1. Similarly, we have found out C3x, which would be cos 3 theta, which is 4 cos cube theta minus 3 cos theta, that is 4x cube minus 3x. So, in general we can write cos n theta plus cos n minus 2 theta would be 2 cos theta cos n minus 1 theta. So, Cnx is 2x Cn minus 1x minus Cn minus 2x. From here we can find out any Cx of any value of n. From here we can write C3x as 2x C2x minus C1x. We know the value of C1x x and C2x already we have found out as 2x square minus 1. So from this in general formula again we find out C3x, which matches the previous finding. Now C4x is also found out, as we know now C3x, we can also find out C4x by the in general formula. Now magnitude of H omega in the pass band would lie between 1 by root over 1 plus epsilon square and 1, because in between 0 to omega p, Cn would have a value of 0 and minimum value of 0 and minimum value or maximum value of 1. And if we normalize A to 1, we have these two values. So from this equation or conclusion, we can draw the characteristics of a Chebyshev filter as this, where the magnitude corresponding to the pass band would be 1 by root over 1 plus epsilon square, which is our del P. So from the definition of 3 dB frequency, we can substitute omega by omega 3, which is the 3 decibel frequency, and the square of the magnitude would be half, because at 3 decibel frequency the magnitude falls to 1 by root 2. So from here this x, that is omega 3 by omega p, is greater than 1, so we use the hyperbolic formula. But the problem here is the mathematical calculation involved in finding the poles is very hectic compared to Butterworth filter. So we will skip those mathematical calculations and we skip to the formula of HAS. As compared to our previous Butterworth filter, there was a pole for odd n, there was a real pole at S is equal to omega C. Here the real pole is at omega p C0. So here the equation for n odd HAS, equation for HAS when n is odd is given here. BK, CK are yet to be mentioned. And for even n, the formula of HAS is this, which you people have to memorize while you solve any problem. Now BK and CK are mentioned herein. C0 is termed as Yn, CK is this, BK is this, where Yn is this. These formulas or equations are to be memorized and used when you solve your problem. Now how to find n and epsilon? See, this HAS is dependent on n and epsilon. BK and CK are again dependent on n. C0 is dependent on Yn is dependent on epsilon. So the two things that we need to write our HAS is n and epsilon. Now previously I have mentioned that del P here is 1 by root over 1 plus epsilon square. From here epsilon can be written as root over 1 by del P square minus 1, and 1 by 1 plus epsilon square Cn square omega S by omega P will be written as del S square, because when omega is omega S, the magnitude is del S. So from the two equations here, see omega S by omega P, that is omega s is higher than omega p. So it is x is here greater than 1. So we have to use the hyperbolic cos formula. So here the value of n would be cos hyperbolic inverse root over 1 by del s square minus 1 by 1 by del p square minus 1 divided by inverse cos hyperbolic inverse omega s by omega p. These are the same steps that we have used in Butterworth. These are mathematical calculations. And for epsilon, we can use this formula, which is already given here. So whenever you are asked to design a analog Chebyshev filter and you are given del S, del P, omega S and omega P, or AP and AS, you first need to find out del S, del P, then you need to find out epsilon, then you need to find out N. Once N and epsilon is given, depending on whether N is odd or even, you have to write the in general equation of HAS. From there, you have to find out C naught, BK, CK using the formula Yn, because C naught is Yn, Yn again is this equation, which is half of within bracket root over 1 plus 1 by epsilon square plus 1 by epsilon whole to the power 1 by n minus of the same term whole to the power minus of 1 by n. This is all about your Chebyshev filter.